Let's take a look at the questions on homework number 3. First, we'll take a look at writing equations of lines from giving a point and a slope using the point-slope formula. So for our first question here, we're asked to use the point-slope form to write the equation of a line that passes through this point and that slope. So let's remind ourselves what the point-slope formula is. So I'm going to color code it with the parts that are permanent and then the parts that are substituted. So we need a point in this order, an x-coordinate and a y-coordinate here, and we need a slope there. Okay, so I'm going to make this a different color because it's a different value. So we were very specifically given a single point here. This is the x-coordinate, this is the y-coordinate, and this is the slope. So all they want you to do is put all of these pieces into the right place by keeping the permanent parts the same and then putting these three values where they belong. So my slope goes here. So I'm going to write -7/4 in the m position. And now it's time to place my x-coordinate, which goes over here, and my y-coordinate, which goes over there. Now they do want you to write it in a point-slope form, but they will want you to simplify this part over here. So we're going to type y minus 6 equals -7/4 parentheses x, but instead of a minus 14, we're going to put a single operation there. So that's what you're going to type in the answer field. Y minus 6 equals -7/4 parentheses x plus 14. If you don't have a keypad on your device, you could always open this virtual keypad here, and you can use these buttons to type. See, my answer is still in point-slope form. So make sure you're writing your answer in point-slope form. So you always start with a y and a minus sign, then you type your y-coordinate. For us, our y-coordinate is given in the point to the right here. And then our slope would be next, and then our x-coordinate would be last. So y minus 14 equals -1/2 parentheses, parentheses should be on the side, x minus, and then we have a -9. So before you click submit, you should simplify these double negatives to a single positive. All right, for the second lesson, writing linear equations from point-slope, writing it in slope-intercept form. So we're going to take this one step further this time. So we're still going to start the same with our permanent parts, right? Still going to start the same with our permanent parts. We're still going to fill in our points and our slopes. 3/5. Ooh, that green is really bright. But instead of leaving it in this form, even if we were to simplify all these double signs, like y plus 2 equals 3/5 x plus 5, they want us to write the equation in slope-intercept form, which means I actually have to do this distributing, and then I have to actually isolate y. So after I do my distributing, I'm going to get 3/5 x plus 3, because 3/5 times x and 3/5 times 5, and then I'm going to subtract 2 on both sides, giving me y alone. Y equals 3/5 x plus 1. Y equals 3/5 x plus 1. Let's take a look. Excellent. All right, let's try one more problem. Again, we're going to put the parts into the formula So y minus 6 equals 1/4 parentheses x minus 8. There's no double signs to simplify, but there is distributing. So y minus 6 equals 1/4 x minus 2. Add 6 to both sides. Y equals 1/4 x plus 4. Y equals 1/4 x plus 4. All right. I'm going to move on to the third topic here. And this one looks crazy, but it's not. They've used a graphing calculator to type this function into their y equals menu to view a table. And these are the points that we were given. These are some of the solutions for x and y. And they would like you to plot these points on this grid down here. And they'd like you to plot all of the integer points, right? Plot at least 2 points from the table of values with integer coordinates. So we don't need to try and plot these more difficult points, but I can plot -8, 3, -8 on the x, +3 on the y. I can plot -5, 2, -5 on the x, 2 on the y. I can plot -2, 1, -2, 1, 1, 0, 4, -1, and if you look carefully, it is following along the same straight diagonal line. 7, -2, and then 10, -3. When I'm done plotting, I'm going to click this button here, Done Plotting Points. Up will appear a ruler, and I know it's kind of hard with a trackpad, maybe if you have a touch screen, but if you mess up, you can always erase your drawing. You're going to want to try and get this virtual pencil to kind of draw, and then it will start to snap a line for you. And if you go kind of wacky, you can just erase the drawing and start again. But if you slide along the ruler, it will create that perfect straight line for you. If you're done, you come down and submit your answer. Okay, let's try one more. This one has a lot of integer points. So let's see if we can just plot a few here. Let's see, I'll pick some from the middle here. -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3. I think I plotted enough. Let's see what they say. I'm going to go from the bottom all the way up to the top. You're not done until you get those 2 arrows on each end. Let's see. Is that sufficient? Yes. All right, now I'm going to move on to the fourth topic from the homework, graphing lines from equations. Now, you can do this by just using your understanding of the slope-intercept form of a line. So this is the slope-intercept form of a line because the number in the M position is the slope, and the number in the B position is the y-intercept. So I know that my slope is 3, and my y-intercept is -3. And slope is a rise and a run, which can be used to plot more points. And if the slope has just an integer value here, you can put a 1 in the denominator of the fraction. So you can use a shortcut, or if you're not sure how to use that shortcut, you simply open your TI-84 calculator, you press the y equals button on the upper left, you enter this equation, 3x minus 3, then you press the blue key second and the graph key for table, and you choose some of these random integer points to plot as well. So you can use a table, or you can plot using the slope-intercept shortcut. So my intercept was -3, and my slope was 3/1. 3 is my rise, 1 is my run. 3 is my rise, 1 is my run. All right, they're going to ask you to plot 2 points to submit your answer. I'll show you one more here. My y-intercept is -2. That's my first point. And then from there, I have to count. From this point, I have to count. A rise of 6, 1, 2, 3, 4, 5, 6, and a run of 5. 1, 2, 3, 4, 5. Click once, and submit your response. And that's how you graph on Delta Math. Now for the next topic, they're going to give you the graph, and they want you to write the y equals mx plus b sentence right here. That's what they want you to do. So we're all going to start with a y equals sign, and they want you to write the equation in fully simplified slope-intercept form. So my y-intercept is -8, and my slope, if I count from this intercept, my slope has a rise of 1, 2, 3, and a run of 2. So a rise of 3, a run of 2, and then next to that is an x. My y-intercept can go at the end. This is an acceptable answer. Or, if you started by counting from your y-intercept, you can write that first, -8. And then a rise of +3, and a run of +2, and you can put the x term at the end. So both of those answers are acceptable and correct. Let's try one more. The y-intercept is 5. So again, if you'd like to start by typing the y-intercept first, you can. Has a rise of 2 and a run of 3. So +2/3 with an x on the side. Now be careful, not all of your lines will be going uphill. Sometimes they'll be going downhill, unlike this one here. Alright, so I paused the video to advance to the next question so I could show you one that is negatively sloped or going downhill. The process is the same. You start with a y and an equal sign, and you can even start with your y-intercept if you like, -6. But you'll notice my rise is going down 1 unit and then over 6. So down 1, right 6 is -1/6 with an x on the side of the fraction. Make sure your x is on the side of the fraction and not in the denominator. The only two correct places for the x is on the side of the fraction or up in the numerator. That's also acceptable. Alright, last topic is to interpret features of a proportional graph. So there's going to be a story for each problem. This one happens to be telling us about number of pounds and total cost. So let's read the story. A grocery store sells sliced American cheese by weight. The relationship between the amount of American cheese in pounds, that's the x values, and the total cost in dollars of the sliced American cheese in y is represented by the graph below. 2 points, A and B, are labeled. Which statement about the graph is true? So let's take a look at these choices. Point A means that the unit rate is 2 pounds per dollar. So a unit rate is when you are comparing your rise to your run. So a unit rate for point A, even though point A is technically 2, 9, right, or a rise of 9 and a run of 2, right, because from the origin we went up 9 and over 2. So this is its location, but that's not a unit rate. A unit rate has to have a 1 in the denominator. So to have a 1 in the denominator, I'd have to simplify this by dividing them each by 2, which would give us a 4.5. So $4.50 for every 1 pound of cheese. $4.50 for every 1 pound of cheese. Point A means that the unit rate is 2 pounds per dollar. No. We just figured out it was $4.50 per 1 pound of cheese. Now let's see, point B means that the unit rate is $4.50 per pound. So let's look at point B. It has a rise of 4.5 and a run of 1. Is that a unit rate? Yes. So this is true. Let's read the rest. Point A means that the unit rate is $9 per pound. No, it is $9, but that's for 2 pounds, which is not a unit rate, right? Not a unit rate. So we're going to click the second choice here for point B. Let's try another one. A company orders box lunches from a deli, which all cost the same price. The relationship between the number of box lunches ordered, X, and the total cost, Y, is represented on the graph below. What point on the graph represents the unit rate? The unit rate has to have a 1 in the x position, right? So from the origin, if I rise however many, and I run over 1, I would have to be on the graph. That's a unit rate. So for us, I would rise 9 and run 1. So this is the unit rate, that point, 1, 9. Unit rate has to have a 1 in the x position. Mia practices the piano the same number of minutes each day. The relationship is shown on the graph below. The point 660 is labeled. Which statement about that graph is true? So the point 6 right here is the x, and the 60 is the y. So anything that's here would be labeled number of days. And anything in the y position, right, for us, which was 60, would be practice time. So in 6 days, there were 60 minutes of practice time. That's what this means. 660. 6 is the number of days, and 60 is the minutes of practice time. So let's see. The unit rate is 60 minutes per day. Nope, because it was 60 minutes per 6 days, right? 60 minutes in 6 days. So x has to be 1 to be a unit rate. The unit rate is 10 minutes per day. Well, we had 60 for 6, and if we reduce this here, we can get a 1 in the denominator, right? So it's 10 minutes per day. So that's true. The unit rate is 10 minutes per day. Unit rate, whoops, I clicked the wrong thing. The unit rate is 10 days per minute. Nope, it is 10 minutes per day. So be careful that you're reading the actual choices. All right, that concludes our video for homework number 3.